Okay, gentlemen, so this document is for download for you in your assignment, right? And this is basically just something I would add to the bottom of your notes for 0.1 about real numbers and exponents. Just some extra practice to go over some basics if this is a topic that's struggling you a little bit. So to start, we're going to do simple problems, and we're going to work towards some more difficult ones. So just kind of get started. Here's our rules up above. Using them for the first problem, we see that we have just a kind of a basic 5x to the 6th over y, and then a 3x to the 4th over y squared. Because you have two fractions multiplying, you can multiply those across. And when you're multiplying across, right, we have nothing in common on the first fraction, a 5 and x and y, no base is the same. And in the second fraction, we have a 3 and x and y, so nothing in common. So we just multiply across. 5 times 3 is 15, 6 times 4, or x to the 6th times x to the 4th. You just add the powers. Y to the first times y to the second, you add the powers. And you get your simple answer of 15x to the 6 plus 4 tenth, y to the 1 plus 2, y to the third. Nice and simple. Okay, looking at the second one, we don't have anything to combine with multiplication, but we do have some division that can take place. So first we have a 2 and a 4. Then we have two x's, an x on top and an x on bottom, with an exponent of a 2 and an exponent of a 1. And then we have a y to the third and a y squared. So when we combine them, right, 4 over 2, that's 2 over 1. X squared over x is really just x to the 2 minus 1, right? You subtract the powers when you're dividing like bases. And then same with y. We have the same base, so we're allowed to subtract the powers. Y to the third minus y squared. And you get y to the, or 2, x to the first, y to the first. No need to write the ones, we just leave them. Okay, looking at the third one, we have our first one where we see something raised to the 0, which means that's 1. Anything raised to the 0 power, including 0, is always 1. Now we look at my 3 and my 9. That simplifies to 1/3. My x to the 0, that's just my 1. That's written in red. And then y to the 4th over y to the 3rd. I didn't write the subtraction up there, but it's 4 minus 3, which is y to the 1st. So then we have just left with a y to the 1st. That's positive. That stays on top. A 3, which is just on the denominator, so that stays on the bottom. And there's my final answer there. Whatever is raised to the 0, just what's raised to the 0, right? 3 in front does not have a power of 0, just the x does. Okay, next one. We see here we have a 3, a y to the negative 2, a z to the 8th, and then a 2z. So since I have the y to the negative 2, I want to move that down to start. So first I move that down to the bottom, right? So now it's a y squared. And then I have a z to the 8th over z, so that's z to the 8 minus 1. Right, so the y got brought down because it was negative, and that is equal to 3. Now z, 8 minus 1 is 7, which was positive, so it stays on top. And then my 2y squared stays on the bottom because it was on the bottom because it was negative from the start. Okay, number 5, right? So we see here we have a y to the 0. So we know that's going to turn into a 1. And now we have a 6 and a 10, so we can simplify that. X to the third over x to the 5th, we can subtract those exponents because they have the same base. The y now has no partner, so he's going to stay on the bottom. Then we have a z and a z to the third on the bottom. So we see that, there's my 6 and my x to the third, right? So I just simplify it, I make it a 1. And now, as I was saying, we have our 3 over 5, which is 6 over 10 simplified. The y stays on the bottom. He's got no one to pair up with. X to the 3 minus 5 and z to the 1 minus 3 gives us 3 over 5y. That stays. X to the negative 2, z to the negative 2. Since they're both negative, I want to put them in their proper spot, which is on the bottom. And we see there. Now it's all written on the bottom, and there's my final answer. So all the powers are on the bottom, nothing stays on top. Looking at number 6, we have a 3, a y squared, which is negative squared, and then a z to the 8th. And then we have a 2y z squared. Okay, so pretty similar to actually number 4, right? So we know that first of all, that I have two ways to do this. So one way is to take that negative power, y to the negative 2, and bring it down from the start. So if I bring that down from the start, I now have 3 z to the 8th on top. I'm going to bring in the y down, 2y. I throw my green highlighted y squared, which is now positive, on the bottom next to my other y. Then I have a z squared. So the only thing I did is I just took that y to the negative 2, which was on top, moved it to the bottom, and now it's positive. So now on the top, I see I have a 3z8 power. Then I have a 2yy squared, z squared. So I can combine those y's, and I can subtract my z's, right? Z to the 8th over z squared becomes z to the 6th. The y's I combined, y to the 1st, y squared gets me a y to the 3rd. And now my z to the 6th, that's going to stay on top because it's positive, so I can slide it next to the 3. And there's my final answer there. And my 2y to the 3rd stays on the bottom. The other option to do this, or, right, instead of doing that, well, I'm just going to leave it and look at my 3 over 2. That stays. Can't simplify that. My y to the negative 2 minus 1. Okay, because I have a y on the bottom, so negative 2, which is the top y highlighted in the green, minus my power of my y on the bottom. And then I have a z, 8 minus 2. Simplify that, 3 over 2, and then I get y to the negative 3, and then I get my z to the 6. Since the z has a positive power, it goes on top, and the y has a negative power, it goes on the bottom, and there's my answer. Same exact answer, just one option, you move it around first, and then simplify. Option 2, simplify, then move it around. Okay, now number 7 and 8, you can kind of see they're really similar. So looking at 7, we have almost the exact same equation. 3, 2 on the bottom, a y to the negative 2, a y on the bottom, a z to the 8th, now it's just a z to the 10th. So going through this one a little bit faster, we see that, y to the negative 2, I can move it down as I did. Okay, and then my 3 and my 2, my y's combine on the bottom, just like I have above, except now I'm going to have a z to the negative 2. 8 minus 10 is negative 2. Since that z is written on the side as a negative 2, I'm going to move that guy to the bottom to be with where it's supposed to be, so it becomes a positive z squared, and there's my answer. Right? So it's nice to see them side by side to kind of see I can do the difference is because it's a negative 2, it slides to the bottom. I also could do it the same way in red, 3 over 2. I have my y to the negative 2 minus y to the 1st. And then I have my z to the 8th and z to the 10th. Subtract those, negative 2 minus 1 for my y, 8 minus 10 for my z. And I have 3 over 2 y to the negative 3rd, and then z to the negative 2nd. Because the y is negative and the z is negative, I can put them both on the bottom next to the 2, and I get the exact same answer as I did above. Number 8, again, very similar, except now I don't have a z on the bottom, and on top I have a negative power. Just like we've been seeing now, the whole thing in parentheses has a negative 2. So that whole thing gets slid down, and the only thing that changes is the 2 on the outside. The only thing I'm doing is I'm taking the whole unit of the 3y, and I'm sliding it down to the bottom because it had a negative 2 power. So the only thing that changed was the outside, because I'm working with the outside only. Now let me simplify that. My z on top stays. My 3, my 2, and my y stuff. Well, first let me expand my green. Right? And when we do that, the squaring goes to the 3 and to the y. So I got 9y squared on bottom, next to a 2y, and a z to the 8th on top. The z to the 8th stays. 9 times 2 is 18. I add my exponents of my y on the bottom, and I get a nice looking answer of z to the 8th over 18y to the 3rd. All right, so keeping in mind the parentheses do matter. That would indicate it goes to the 3 or the coefficient. Other option would be, well, I could kind of distribute it first. So I have my 3 to the negative 2, my y to the negative 2, and my z to the 8th on top, and my bottom's 2y. If I do that out, it gets a little weird. I don't like to do my distributing of my power when I have a coefficient like 3 or 5 or 2 or whatever, because then it gets a little weird, because we see here we have a 3 to the negative 2, and as you see, I kind of have to write that a little awkwardly, so I don't like to do it when there's a power that's negative, and it's doing that to a coefficient, a number. It's kind of weird. With variables, it's okay, but with numbers, it's a little weird. So that 3 to the negative 2 is really a 1 over 9. And then the y to the negative 2 is just y squared, but it's got to be on the bottom. So I kind of write this as two fractions. A little weird. But then we multiply across, and I get my z to the 8th over 9 times 2 and y squared times y to the 1st. So I get 18y to the 3rd on the bottom. Same answer, but as you can see, this way is a little weird. I kind of prefer the blue way, because when I have a negative power and a coefficient that's a number, it acts a little weird. Okay, almost done, only two more. Looking here, 4x to the 3rd to the squared, so that's all positive up there. And then I have my y up top still, 8x to the negative 3rd, y to the negative 3rd. So first thing I see is I have this, negative 3. So I'm going to slide that up. I just put it all on the outside, I'm just going to slide it up. And then kind of at the same time, I have my 4 squared and my x to the 3rd squared. So I'm kind of distributing that squared, all positive, 4x to the 3rd and squared, all positive. Just my x to the negative 3 on the bottom, I slide up in green. So I distributed my power to the thing in parentheses, slid up my x. I'm going to simplify that, 16x to the 6th, right? Because a power raised to a power, multiply the exponents. Then I have my y, x to the 3rd, and my bottom staying the same so far. When I simplify that, I have my 16x to the, got to add the 6th power with the x to the 3rd power. My y is just hanging out up there for now. And I have my 18y to the 3rd, my 8y to the 3rd rather, on the bottom. Okay, and I have my 16x to the 9th. I added those powers. I did my subtraction now, so I have y to the 1st on top and a y to the 3rd on the bottom. So it's 1 minus 3. And my 16 and my 8, I know I'm going to be able to simplify too. So I have my 16x to the 9th over 8, and then my y became a power of negative 2. That's going to slide to the bottom, and I'm going to simplify my 16 over 8 to 2 over 1, and there's my final answer. The other way to do this, right, is to leave the x on the bottom as a negative 3, because I don't have to slide it up right away. I can do that later. So I do exactly as I did above. I put the squared into the 4, the squared into the x to the 3rd. My x to the negative 3 is still on bottom, no change. When I simplify that, I still have my 16x to the 6th, as you see right above it. My y is on top still, and then I have an x to the negative 3rd on bottom and a y to the 3rd on bottom. Now, a single fraction, let's just do our normal steps here. I have x's on top, y's on top and bottom, and then my numbers. So my 16 over 8, that's 2 over 1. X to the 6th minus x, or divided by x to the negative 3rd, means 6 minus negative 3. And y over y to the 3rd is y to the 1 minus 3. Keep, change, flip. So do that subtraction. I get 2x to the 9th, y to the negative 2nd. So the only thing that has to be slid down is my y. There it is. And I get the same exact answer. Right, so all these problems are here to show you that you can either move things up to start and then do it out and simplify, or leave it and move it later. Right, leave it and move it later. So this is one like the homework that you guys had due from your last live class, just like one we had. Again, I'll do this one two ways. So the first step you can do is either flip the purple and the green, right? Both of those have a negative power on the outside. Okay, so I can flip them entirely to start, as you see here. Everything in purple goes to the top, and the only thing that changed was my 3 on the outside became positive. And then in green, slid to the bottom. The only thing that changed was my 3 on my outside. That's it. Because the only thing you're doing is you're moving the whole thing. So the only thing that's changing is the whole thing in parentheses, which had the 3 on the outside. Anything raised to the 0 is 1. Okay, now we're going to distribute my powers. 2 to the 3rd, x to the 0, which is just 1 to the 3rd, and then y squared to the 3rd. My z's are just hanging out in blue. No flipping, just leave them. 4 to the 3rd, x to the negative 3 to the 3rd, and y to the 3rd. Simplifying that out, 2 to the 3rd is 8, 4 to the third is 64. And when I have something raised to a power, and then to another power, I multiply them. So I get here 8 and 64, there they are. My y to the 6, because it's y to the second to the third. Z on the outside still. X to the negative 3 to the third is negative 3 times 3, so negative 9. Y to the third and my z to the fourth. Now I have one single fraction. I'm going to simplify my 1 over 64, or 8 over 64 to 1 over 8. And then I'm just going to start to pair things off. I do notice that I have an x to the ninth that's negative, and it's on the bottom. So why don't I just move that up now? And you'll see in the next example, I could move it later, but I'm going to move it up now. So now I have that my x to the ninth is now positive on top. My 8 and my 64 become 1 over 8, and I'm leaving those for now. I did my simplifying for 8 over 64. I made it 1 over 8. My x to the negative 9, I moved up and made it x to the 9. Okay. Now I have a y to the 6th and a y to the 3rd. I subtract those powers. A z and a z to the 4th. I subtract those powers because they're dividing. And I'm left with 1 over 8 x to the 9th, that stays. Y to the 3rd and z to the negative 3rd. The y goes up, the z goes down, and there's my answer. Last way, doing the exact same thing, or what I could do is distribute first. So just as we've seen, if we kind of do my power distribution first, I'll get the same answer. So 4 to the negative 3rd. I don't like to do it this way. Like I said, when there's a coefficient, it acts a little weird. But the 4 gets negative 3rd, negative cubed. The x to the negative 3rd gets negative 3rd. The y gets negative 3rd. And on the bottom, the 2 gets a negative cube. X to the 0 gets negative cube. We know what's going to happen there. And then a y squared to the negative 3rd. And then my z's, again, are still hanging out. They're all fine. Those are weird, right? They're both negative. So I want to flip their positions. And I see I do that here. I kind of did a little bit of simplifying too. So I flipped the 2 and the 4. I think I have it. There we go. And made them positive. That's why I don't like to do it this way. It gets confusing with the numbers in front. The x to the negative 3rd to the negative 3rd becomes x to the 9th. So now it's positive on top, which is nice. My y to the negative 3rd. There we go. And my z, looking at the bottom. X to the 0 to the negative 3. That's just x to the 0. Y to the 2 to the negative 3rd is y to the negative 6, and z to the 4th. We know what happens with my x to the 0. That becomes 1. And now let me just simplify what I have. So now I have an x on top that stays. The 2 to the 3rd I do. The 4 to the 3rd I do. Now I have two y's, top and bottom. Two z's, top and bottom. Just like we always do, we're going to subtract those powers. Negative 3 minus negative 6. And then 1 minus 4 for my z. And the other one was for the y. Simplify my 8 and my 64 and do my subtraction of powers. I see 8 and 64. Oh, that's still there. Y to the 3rd, z to the negative 3rd. The y is going to go up, the z is going to go down, and my 8 over 64 is going to simplify to 1 over. Oh, that should say 1 over 8. My apologies. That should say 1 over 8 here. Okay. Well, I have to do it like this. 1 over 8. So there's my 1 over 8. Okay? I think I actually forgot my 8 over here too. This should be, my 8 should be over here. And this should be a positive 3. Well, apologies on that one too. That's a 1 over 8 z to the positive 3 over here. Okay, good. Right, so we see we get the same answer. And hopefully this is helpful in just showing you that if you flip it to start or like distribute it to start, you get the same thing. And as long as you're working nice and slow, finding your similar bases, you should be fine.